In this video we're going to look at functions, and this is part of our A21 A-level mathematics. A function is a mapping. Basically it's a relationship between two sets. So the first set is called the domain. So the domain is where you start, and the second set is called the codomain. So the codomain is where you finish. So a function is a mapping where each element of the first set is mapped to one and only one element of the second set. Each element of the first set is said to be mapped onto its image in the second set. This set of images is called the range, and it is a subset of the codomain. Okay, so let's break all of that down. So, number of letters in a name. We'll look at this and then we'll explain what all the different words mean here. So, the number of letters in the name. So, Bob has got 3 letters. John has got 4 letters. Steve has got 5 letters. Amy has got 3 letters. And Pauline has got 7 letters. Now, your domain, it's said up above, your domain was where you started, so the domain. And how you do, this is like set notation, how you do this is with curly brackets. And you'll see these on your keyboard, curly brackets like this. So, and you've got J, B, S, A, and P. So I've obviously just abbreviated all their names there, and then the curly bracket on the end. So that the codomain is everything in the input set. The domain is everything in the input set. The codomain then is everything in the second set then, so where you end up. So you've got 3, 4, 5, 6, 7, and 8. However, the range is everything that is actually covered. So the range doesn't include the 3, 4, 5, 6, and 7. It doesn't include all of them. It includes the 3. It includes the 4, it includes the 5, and it includes the 7. So the range is just 3, 4, 5, and 7 in this particular example. Okay, so the domain is where you start. The codomain is where you finish, but the range, very importantly, it's a subset, so it's a smaller set within a set. It's a subset of where you actually finish. So the range was just the 3, the 4, the 5, and the 7. Okay, let's look at this one and see, is it a function? So let's go back and look at the definition. It says, a function is a mapping where each element of the first set is mapped to one and only one element of the second set. So let's have a look. John goes to one thing, Bob goes to one thing, Steve goes to one thing, Amy goes to one thing, and Pauline goes to one thing. So this is a function. And it says here, this is an example of a many-to-one function. So it's a many-to-one function because well, there's only one instance of it happening, is there? Yep, Bob and Amy. Bob and Amy both go to 3, so that's why there's many things going to one element. So that's why it's called a many-to-one function. Okay, so if say Amy had been scrubbed out here, which she didn't exist, it would have been just what's called a one-to-one function, because John would have gone to one thing, Bob would have gone to one thing, Steve would have gone to one thing, and Pauline would have gone to one thing. So it would have just been what's called a one-to-one. This is also called an into function, as there is an element in the codomain, there's an element in the codomain which are not included in the range. So the codomain, or more than one element actually, but the codomain and the range are not the same. Okay, next example. Same idea, they've got the arrows drawn on for us in this one. This is position in the class. So it must be some sort of test going on, and they've figured out what the position in the class. So the domain is where you start. So the domain is just John, Bob, Steve. And then the codomain is a complete set, so just turn your brain off. Complete set of where it goes into. And then the range is specifically where it goes into. So in this case, it actually does cover everything. So it covers the whole codomain. So we'll see what this means. So first of all, this is a one-to-one function because John goes to one thing, Bob goes to one thing, Steve goes to one thing. But it's also an on-to function. So that's just because everything in the codomain has been covered. The whole codomain has been covered, and the range and the codomain are the same. Okay, our next example, it says sports played, and you've got John, Bob, and Steve are playing different sports. So domain again is where we start. So domain, we've got John, Bob, and and Steve. The codomain is where you finish. So you've got, I'll just abbreviate these again. Instead of writing rugby, I'm going to write R. Instead of writing cricket, I'll write C. Instead of writing athletics, I'll write A. So that's what we've got. Okay, our range is exactly the same as well. It's R, C, and A. Right, now this is where it gets a wee bit strange and is a bit of a different function. This is not a function, and the reason it's not a function was the definition of a function was a mapping that takes one element to one and only one element in the second set. But if you have a look, John plays rugby and he also plays athletics, so one element goes to two elements. Likewise, Bob's fine, he goes does one thing, but Steve goes to two things. So it's actually what's called a this one is called a many to many. So because there's two of them which go to more than one thing, so that's why it's a many to many. You could also call this a one to many function as well. So one goes to many, and that's a more common way. Really, this second one is a more common way to say it. So it's a one to many mapping, which is not a function. Okay, if we have a look at the next one, it says consider a relationship between the two sets of numbers below. So if we look at this, and let's think about what's going on, and they've said it's a relationship, so they haven't said it's a function. We don't know if it is a function just yet. Let's have a look at it. 1 goes to one thing, minus 2 goes to one thing, minus 3 goes to one thing, minus 1 goes to one thing, 4 goes to one thing, and 2 goes to one thing. So it's definitely a function because the element goes to one and only one element, so that's fine. But what it is, it's a many to one function. So for a many to one function, that's what this thing is, because you've got more than one thing going to the same things, but it's still a function. If you were to reverse this, however, this is very important. If you were to reverse this, so find, or instead of reversing, the word is inverse, find the inverse. 1 would go to 1, and 1 would also go back along to minus 1. Likewise, 4 would go to minus 2, and 4 would go to 2. So the many to one function is fine, but its inverse would not work. You'd have to do something a wee bit special, as we'll see later on, to make the inverse actually still be a function. Okay, a wee bit of definition here, notation I should say. It says we say that x is mapped onto y, and we write f. What this means, f, the double dot means such that x goes to y. We use f for the function and the double dot for such that, and means f operates on the input x to produce y. So you could also say y is equal to f of x, but they're very fond, when we're talking of functions, they're very fond of writing it this way. So it means the same thing. If you think about it here, f of x means you put x into your function and out comes y. Same thing here, you have your function and x becomes y. So y is called the image of x. So y is called the image of x. So here, for example, up here, 1 is the image of 1, 4 is the image of minus 2, 9 is the image of minus 3, 16 is the image of 4, and so on. Okay, the function in this case is, if we have a look back at what it was, 1 goes to 1, minus 2 goes to 4, minus 3 goes to 9, minus 1 goes to 1, so it's clearly a squaring function. So the function is square the input, so we would write f of x is equal to x squared, or f is such that x becomes or goes to x squared. And just another wee set of notation here. R, this special looking R, means a set of real numbers. So x, and this means x belongs to, they've said it a slightly different way, but I would write that as belongs, excuse my terrible handwriting, x belongs to, x belongs to the set of reals, i.e. x is a real number. Okay, we're going to look at a few graphs now. We're going to decide whether they're one-to-one function, many-to-one function, one-to-many function, or maybe many-to-many. So we'll have a look and see what's going on here. So if you have a look at this one, first of all, we'll look at your x values. As your x values go along, so we'll just pick an x value at random. So we'll pick -4. So -4 goes to -2, -3 goes to whatever that's going to be, -1.5, -2 goes to -1, -1 goes to -0.5, and so on. 0 goes to 0, 1 goes to 1 goes to half, 2 goes to 1, 3 goes to 1.5, 4 goes to 2, and so on. So clearly, just by looking at it, you can see one value goes to 1 and only one. One x value goes to 1 and only one y value. So it is a 1 to 1. Okay, so let's just look at the domain. Now the domain obviously goes on beyond what we've got here. So the domain is x belongs to the set of reals. The range is f, so it is, it's f really, or really it's y actually, sorry, we've used y here. I didn't say x belongs to the set of reals. So the range is y belongs to the set of reals as well. So you imagine, as I continued out this way, my x values are going to go all the way out this way. My x values are always going to go out this way as well. And same for my y, it's going to go infinitely up and infinitely down as well. So that's why we've got those. So x belongs to all the reals, and y also would then belong to all the reals too. In this second graph, we can see we have got it's a cubic function. And if you just pick a couple of values, pick this value here, which would be whatever it would be, -2.5. -2.5 goes to one value. -1 goes to one value. 0 goes to one value. 1 goes to one value. 2 goes to one value. But if you were to draw a line across, you can see there are multiple things which go to a y value of, say, whatever that is, 6. Okay, so it really is a many to 1. So if you draw a line across, you can see there's multiple things go to the same y value, so it's a many to 1. So your domain for this domain is again x belonging to the set of reals, because this exact graph would exist out this way and out this way, and the range, and again this graph would go all the way down to -infinity all the way up to positive infinity. So the range is y belongs to your set of reals, so it takes all the real values as well. Okay, in this graph we can see, if you draw a line vertically this time, there's one x value goes to two different y values. Likewise here, one x value goes to two different y values. Likewise here, one x value goes to two different y values. So really it is a one to many function, or one to many mapping, I should say. It's not a function, as the definition of function is one element goes to one and only one element. So it's in its current form, it is not a function. So we just put a wee reason in there for it. The reason for it is it's one to many, as 4, for example, goes to 2, and also it goes to -2. So the domain, a wee bit trickier for the domain. It's x belonging to the reals, set of real numbers, and then the wee double dot, remember, means such that, and then x is greater than or equal to 0. So the reason for that is the graph does not exist out this way, so it only exists from here out. So, sorry, apologies. It only exists from here out, so which is x is greater than 0. And the range is y belonging to the reals. Let's see if there's any restriction on this. There's not, because you can see it will go up to positive infinity and it will go down to negative infinity as well. So your range is just y belonging to the set of reals. Okay, now we've got this graph, which is a lovely heart shape. The function is x squared plus y squared minus 1, and then that's cubed, and minus x squared y cubed is equal to 0. Do not worry, you don't need to know that for an exam or anything. Right, this function if you were to draw a line vertically, you can see one x value goes to many y values. If you draw a line horizontally, you can see one y value goes to many x values. So, or you could say this really is going to be a many to many. Okay, so the domain of this one, and just use your graph to have a look at it. Clearly x belongs to the set of reals, but it doesn't keep going out to infinity, minus infinity, or positive infinity. So it seems to stop here at this edge and at this edge. So it is x belonging to the reals, that's correct, but it is such that it's minus 7 is less than or equal to x is less than or equal to 7, and so on. And the range then, it's y again belonging to the set of reals such that, and again the lowest point is going to be whatever that is, minus 6, and the highest point, not 5, remember, goes all the way up to here, so whatever that looks like, it looks like 6.5. So minus 6 is less than or equal to your y is less than or equal to 6.5. Okay, just going to look at a couple of wee graphs. Just if you really know and understand your basic graphs, it makes mathematics so much easier. So there's only a few that we actually have to learn. Okay, first on our most basic graph then is just y is equal to mx plus c. So this is just your straight line where m is a gradient. So m is a gradient and c is the intercept. So you'd get your m just by finding the gradient. So your vertical distance over your horizontal distance. And your c is just where it crosses the y-axis. Next one is our quadratic. This is a positive quadratic. So if a is greater than 0, then it's a U shape. If a is less than 0, then it is an N shape. So it's greater than 0, so it's a positive quadratic, and a positive, so smiley face. And a negative, a is less than 0, would be a negative quadratic and a sad face. Okay, this is our positive cubic graph. And the first bit, the A is positive. It has that general shape, but the rest of it tells you what happens with the rest of the graph. So there are lots of different ways that this thing can go. So that is one positive graph. Another one, positive cubic, sorry. The most basic positive cubic is y is equal to x cubed, and it looks like this. So it has a point of inflection. So that's where it goes positive, 0, and positive again. Whereas these ones actually have, this one they've shown here has a maximum value here, and a minimum value, and then it goes back up again. Had this been a negative quadratic, I find these ones tricky to draw, but a negative quadratic goes down that sort of shape, or maybe that sort of shape as well. Not good drawings. Okay, and we've got our exponential graph. Exponential graph, e to the x, it just looks like this, and the horizontal line is an asymptote. So the x-axis, I should say, is an asymptote. So this x-axis here is an asymptote, so it gets infinitely close to it, but it never actually gets there. And also, if you put x equal to 0, e to the power of 0 equals 1, so it crosses at 1. So that's y is equal to e to the x. Also worth your while knowing that y is equal to e to the minus x is the same graph, but it's just reflected horizontally. You can imagine this one here being exponential growth. Something is growing exponentially. And this is exponential decay. Something is decaying exponentially. So that's it. Okay, right. Very important then. This graph, the next graph here is y is equal to ln x. Now I have never actually learned the drawing of y equals ln x, and I'll tell you why. Because every time this one is in my head, y is equal to e to the x. And if you look at your calculator, y is equal to e to the x and y equals ln, or e to the x function and ln function are on the same button in the calculator, which is a big clue that they are inverse functions. And what we'll see later on is to get an inverse of a graph, you reflect it in the line y is equal to x. So if this e to the x crosses at 1, here on the y-axis. It's going to cross at 1 here on the x. The ln is going to cross at 1 on the x-axis. So very, very roughly, there you go. That's my y is equal to ln of x graph. And you can see we've got it drawn properly down here. So just run through it again. If you know your y equals e to the power of x graph, your exponential graph, you can get y is equal to ln x by reflecting y is equal to e to the x in the y line y equals x. So you can see here is your ln of x, and again if I started with my ln of x, I could get to my e of x graph by reflecting. So it would be y is equal to e to the power of x. Okay, last one on this page is our reciprocal graph. Y is equal to 1 over x, and this is a positive one where the y-axis is an asymptote and the x-axis is an asymptote. So that means the graph gets infinitely close to it but never actually touches it. Okay, we're going to look just at this one, y. There's what's called a discontinuity here. So what I mean by discontinuity, your graph goes along here and then you have to lift your pen off the page to draw the rest of the graph. So there's a break in the graph, so it's not a continuous graph. You should have remembered that when we looked at location of roots. If you look up that video, if you don't know what I'm talking about, location of roots, we talk about continuous graphs. So there's a discontinuity here, which means you have to lift your pen. So that means there's a break here. Why there is a break, and this is a very easy way of you discovering where there's going to be a break or a discontinuity, is because if you have a 0 on the bottom line, basically in mathematics, it causes problems, because causes all sorts of problems and difficulties. So 1 divided by 0, if you do it in your calculator, it'll come out with a maths error. There's a problem. So here, that's how I know there's going to be a discontinuity here. So if I change this graph to be y is equal to 1 over x minus 2, this graph, the 0 would happen whenever the x is equal to 2. So this graph would look very similar to the one I've just drawn, but it's going to be at 2 is where the discontinuity is going to be. So that's something to look for. Another important thing, say I was to draw y is equal to minus 1 over x, it would look like this, top left and bottom right, as opposed to what we had earlier on, which was top right and bottom left. Okay, this one says find the range of f of x is equal to 10 over x, stating if it's many to 1 or 1 to 1, and if the domain is x belonging to the reals such that x is greater than 0. Okay, first thing we're going to do for this, the easy way to do it is just a sketch. So our sketch is like this. It's our reciprocal graph. It's our last reciprocal graph, our last example here, which is a reciprocal graph. And get rid of those things that we can actually see. Okay, you can see it's just top right, bottom left. But here in this one, it's just in the top right because it tells you x belongs to the reals and x is greater than 0. So it only exists in here, so that's all we have. So if you have a look at, so this is your function, and we have to look at the range and decide what it is. So for the range of this one, the range, it is f belongs to the set of reals such that, and then f, it would go up to infinity, but it doesn't even exist down this way, it doesn't exist down that way. So it is such that f is greater than 0. And it's not greater than or equal to, because remember, it doesn't actually touch this horizontal. That's as far as we can go. And if you look at this graph, it is a 1 to 1 function. Okay, this example says find the range of g of x, which is equal to 2 minus x squared, stating whether it is a many to 1 or 1 to 1 function if the domain is x belonging to the reals. So all reals basically is where it starts. Okay, first thing, just do a sketch of this would be the best way of doing it. There's your y-axis, there's your x-axis, and this is a negative quadratic, And if you put x equal to 0, your y value is going to be equal to 2. So it crosses at 2, and then it's a negative quadratic, and it's going to be symmetrical. It's going to be like that. So that's what your graph looks like. It would obviously continue on down. So there's your g of x, which is equal to 2 minus x squared. Okay, it is a many to 1, and we'll go through why that is. So it's a many to 1. So it's a many to 1. So if, for example, this value here, this x value would give you a y value here, and this x value would give you the same y value. So there's two values, many of them, going to the one same value. So it's a many to 1. The range of this function, the range is, and it was g, so g belongs to the set of reals such that it can go all the way down to infinity, but it has an upper limit here of this 2. So it is, the range of this thing is g is less than or equal to 2. And that is all we have to do in this question. Yep, so many to 1, its range, and we've got a wee sketch of the function. Okay, and this example says the function f of x is defined as f of x equal to x squared minus 2x minus 8. And it says find, first of all, it's for x belonging to the reals, and part A is very easy. It just says find f of minus 2. So that's just testing your understanding. That just means fire minus 2 through the equation and see what you get. So that's what you're putting into your calculator. And that what that would give you would be 4 plus 4 minus 8. So it would give you 0. Part B says solve the equation f of x is equal to 5x. So that means just 5x is equal to x squared minus 2x minus 8, which means 0 is equal to x squared minus 7x minus 8. I'll just go over here to finish it off. Factorize that, you're going to get x minus 8 upon x plus 1, which means x is equal to 8, or x is equal to minus 1. Part C, it says by completing the square find the range of f of x. So this is using something from your AS1, I think, completing the square was on. So I'll just write out my f of x. It was x squared minus 2x minus 8. I'm going to isolate my x squared term and my 2x term. So I haven't done anything except firing brackets around them. And then what I'm going to do is complete the square. So you half the coefficient of x. So the coefficient of x, I have it highlighted, is minus 2. Half the coefficient of that would be minus 1. So add in minus 1 squared, then minus 8, and then you must take away minus 1 squared again to keep that balanced. So from this line, from this line to this line, what I've done inside the bracket, I've added in minus 1 squared. That means outside I have to take away minus 1 squared. Okay, so if you do that, and your big bracket here just becomes x minus 1 is the same as x minus 1 all squared, then you've got minus 8 minus 1, which is the same as x minus 1 squared minus 9. Okay, so that means it has a minimum value of minus 9. And that happens when x is equal to 1. So if we just do a sketch of this graph, there we are. It's at, won't let me rub this out for some reason. Right, we'll ignore that. Just that's going to be at x equals 1 minus 9 is my minimum value. So my range, your range really in these questions is just your y value. So my range is f belongs to the set of reals such that, and the minimum value of f was minus 9, so such that f is greater than or equal to minus 9. And that's it. Okay, last bit of notes for this very long video, and apologies for the length of this video. We're looking at reciprocal graphs and asymptotes. I talked about this slightly earlier on in the video. Basically, to find reciprocals in a graph, you want to find where there's going to be a 0 on the bottom line. So, for example, in this graph here, y is equal to 1 over x. If x was equal to 0, I would give you a 0 on the bottom line, which means there's going to be an asymptote whenever x is equal to 0. So in this first example, it says sketch the following, indicating all asymptotes. You need to know, and this is why it was so important we looked at those earlier on, the general shape of your general reciprocal graphs. So I'm just going to put that down. That's what my y equals 1 over x looks like. So here, I'm just going to say x minus 2 equal to 0 when x is equal to 2. So that means, that tells me in this particular one, that tells me when x equals 2, when x equals 2, there's going to be an asymptote. So x equals 2 is the value that gives you the 0 on the bottom line, so it's what causes a problem. So this is just very, very rough here, folks. This is just a sketch. So that's 2 on my x-axis, and then it has the same general shape as up above. So top right, bottom left. So now it's top right, right of the asymptote, and bottom left of that asymptote as well. So it is just a sketch here, folks. It's not going to be pretty. Doesn't matter. And there you go. That's what your graph looks like. That's very bad, that one there. But sure. So it gets in. It should get infinitely close to this asymptote, this vertical asymptote at x equals 2. Can you label that, please, for us? So you've got x equals 2 written down for your asymptote, and that's it. Okay, let's just zoom in at this bit first of all. And there's going to be an asymptote when x equals minus 3, I should have said. So when x equals minus 3. So let's mark on a minus 3. So that's x equals minus 3. There's minus 3 on your axes as well. And then if you just had this graph here, this graph that I've circled, 2 over x plus 3, and then you added 1 to it, what adding 1 to it would do would be shifting it up 1. So whereas in this graph, the y-x-axis was an asymptote, I'm going to shift it up by 1. And now my line y equals 1 is going to be an asymptote as well. And my number 2 at the top here is positive. That means it's still top right and bottom left of my 2 asymptotes. So my vertical asymptote, my horizontal asymptote, they are equivalent in this first example, in this first question, as your new y-axis and your x-axis. So as if the y-axis and x-axis have just shifted up to here, or your origin has shifted from here to here, I could say, and then it's still top right and bottom left. So very, very easy. Once you get the asymptotes, they're ridiculously easy to do these questions. Okay, the last two are just 2 standard ones, and I think it's well worth your while to learn these ones just. So remember, your y is equal to 1 over x. It was just top right, bottom left. So y is equal to minus 1 over x would be top left and bottom right. So it has the same asymptotes. It has the y-axis as an asymptote, and it has the x-axis as an asymptote. Okay, and the last one, it's 1 over x squared. And again, I would just learn that one off. So it's both top right. Sorry, both of the top ones, top left and top right. So if you as well just add in an extra one, if you drew y is equal, so that's y is equal to 1 over x squared. If you draw minus 1 over x squared, it would be same idea, except it would be bottom left and bottom right. Okay, that is us done.